Hello, my name is Jake. I will be doing some of the fundamentals of this platformer here, the minimum viable product. So the first thing that we need is a player and a floor. So in your sample scene over here, this is called the hierarchy, this area over here, right click, then you're going to create 2D object, sprites, a square, name this floor, and its scale over here in the inspector, set its x dimension to be 10, its y dimension to be 0.5, and then in the scene editor, go to the move tool, move the platform down a little bit. Then you're going to add component over here back in the inspector, box collider 2D. And that's the floor. Now you're going to right click, create 2D object, sprites, another square, call this one player, set its scale to be 2 over here in the inspector in the y direction, add a box collider 2D, and add a rigid body 2D. On the rigid body 2D, in the constraints area, click on it, and then freeze rotation on the z-axis. Perfect. Under interpolation, set that to interpolate. Then we can get started on a basic movement script. So in your Project Explorer down here, create a folder, call it scripts, open up your scripts folder, right click, create a mono behavior script, and call this player controller. Open it up. And now we can modify that. Let me open it up over here so I know what I'm doing. Perfect. So Unity uses C# under the hood, and as such is object-oriented, so we have to worry about public and private methods and fields. So the first thing that we need for a player controller is some inputs. So I'm going to serialize field private key code left is key code dot. We're going to use WASD to move around. So how this works is serialize field means show this in the inspector. Private means that other objects or functions can't change it. Key code is the data type. This just, what key is it? And then name right here. So we're going to also add we're going to add keys for right and for left. D, and another one for jump. So I'm putting underscores here in front of the names just to denote that it's private. You don't have to do that. That's just a stylistic thing. So now we're going to set up some values that will be used to change the player, their movement. So let's just call these movement values. So again, serialize field, private float, maximum speed, 10.0f. The F denotes that it's a float. If you don't have that, it will be a double and you'll run into type errors. So I'm just copying from the scripts that I've already written so that we don't have to guess on these values. Okay, I went back and deleted the fall threshold because that is not a part of what I did for the scripting. Okay, anyways, now I need to get the rigid body of the character, which is what controls the physics. So, physics things. So we're going to make this private not serializable field because since it's on the same game object, we can just grab it under the start function and not worry about it. So this is the rigid body, and then we're going to also make a bool for is grounded. Okay, so with that, we've got all of our variables set up, and we just need to start assigning them. So the first one is the rigid body, and we're going to use the getComponent method for that. So what that'll do is it'll go on the current object and just get the rigid body 2D component and just assign it there. And now let's just have it do a check. Okay, so now it'll just check and let us know if it fails to get the rigid body. So next up is just update, which is going to happen once per frame. So we're going to put two functions in here. One is get player movement, and the other is going to be ground check. So make a new function, void get player movement, and in here we are going to use the stuff that we got earlier. So first we're going to handle the horizontal movement. And to change the velocity, we're going to use the linear velocity field of the rigid body 2D object. All right, and then else if input.getKey right, and we can actually get rid of that, okay. And then lastly, we want to make it so that the player will stop if we're not pressing any keys. So it should just be else. What we're using here is a lerp function, which is short for linear interpolation, which will just smooth our motion so that when we start or when we stop moving, it's not sudden, it's just a very gentle drop off. Feels more natural, essentially. And time.delta time right here. Oh man, my X is double typing. Time.delta time is just the time between your frames. So for 60 FPS, which is probably what it'll run at for most of us, that's going to be about 16 milliseconds. And this friction just determines how much it should slow by. So we just use it there. Perfect. So now we have to handle the jumps. Notice how we're using getKey down instead of getKey. That way it'll only happen once when you press the button instead of every frame when you hold the button. And this up here, we actually need to add the condition that it is grounded. So that way the player can't just keep jumping. Perfect. So that is our getPlayerMovement function done. Now we need to make our checkGround function. So for this, we're going to be using raycasting, which sounds scary, but it's very easy. Basically, you have your player, and they're just going to shoot a ray downwards, and it can tell you the hit point of the ray, and then you subtract those to get the distance. And then if that's less than a certain threshold, you're allowed to jump. So okay, so what this line does is this creates a raycast hit, which is the result of the raycast function, which will happen at the player's position, and it will go directly downwards. That's what -1 times vector2 dot up means. So if we get a ground hit, then we need to find the distance, figure out if it's less than a threshold, and then update is grounded accordingly. So this line right here calculates the distance between the ground and the player. So how this works is this will check if your ground distance is less than half your scale, since your transform is at the center of the player. Then to get to the bottom of the player would be half the vertical scale, and then we add just a little bit more so that we know if we're hitting the ground. Is grounded equals true, and then we just need to add the false cases for otherwise. And then another one down here in case the raycast does not hit. Perfect. Now we just have to go back to the editor and put that stuff in. No errors, please. Dang it! Okay, the name ground check does not exist in the current context. Where is that? Line 34. Right. I called it ground check here. It needs to be ground check down here as well. Let's go back into Unity. There we go, no errors. So if we go onto our player now and we assign them the player control script, they should be able to move. Let's find out. All right, they fell down. Moving right moves right, moving left moves left. We can't move up though. And why is that? It's because our raycast distance, the raycast is colliding with the player. So to fix that, we need to select the player over here in the hierarchy. Then in the inspector on the layer, set it to ignore raycast. Now if we play again, it should work. We should be able to jump. Yeah. Okay, why isn't this working? Alright, here's where the issue is. I accidentally said not is grounded here. Needs to be grounded to be able to jump. Now, that's the wrong thing. Now if we go back, it should all work. Hopefully. Did I save it? Yes, I did. Weird. It's not recompiling. There it goes. Alright. Okay, it just re-imported the assets as I was playing, and now the jumping works. So perfect. Okay, so that is the fundamental player script done, but notice how at the moment when the player moves around, it moves within the context of the screen and the camera does not move along with the player. That'd be fine if your platformer was really, really small, but we want the platformer to be able to move and take up more scale. So to do that, we need to implement Cinemachine. So go up here into Window, go down to Package Manager, go down here to the Unity registry and search Cinemachine. And install that. Okay, now I'm going to work on Cinemachine. It's been installed. So if we go back over, we could close this window. There it goes. If we go back over into our hierarchy, you can right click, go down here to the Cinemachine window, targeted cameras, 2D camera. So that's our Cinemachine camera. If you go back to the main camera object, you can see it has the Cinemachine brain on it. Pretty interesting. So if we go back to our Cinemachine camera, we need to give it a tracking target. That is going to be the player. The lens size just defines how big the game is. So if I go over here to the game window, you can see as I change the lens size, it'll zoom in and out. I think about 7, it's about right. Okay, so now if I were to play the game, you would see that the camera will smoothly follow the player, up, down, left, and right. Beautiful. But these annoying marks are in the screen, and we want to get rid of those. Okay, so a real quick note, in the Cinemachine camera, this should stay position composure, but up here, game view guides needs to be set to disabled. That'll get rid of those annoying things. So, now that we've done that, we can talk about level design. So right now we've just got one floor, which is pretty boring. So I'm going to use Control-D to duplicate the floor object, and then I can drag it over. And now we've got 2 objects that we can jump between. But that's kind of boring still, so let's add a third. So use Control-D again, but this one we're going to make it move. So go over here, press F2 to rename, call it Moving Floor. You can change its scale if you want. I'm going to change it to be 4 instead of 10 in the X direction. Perfect. Now we need to create a new script, so right click down here, create mono behavior script, call this, let's call it platform controller. Perfect. So once we've got that, let's open it up and we can start changing things. So in here, we need to get our goal position offsets. So again, we're going to use serialized fields for that. All right, perfect. Next, we're going to get some move time. Perfect, and again we're using private serialized fields so that these values can't be changed, but they still show up in the editor. Perfect, so now all we need is some variables to hold some information. delete this space here. Perfect. So once we've got all of these, then all we need to do is get the player's rigid body, which is how we're going to have the player stay on the platform. Because if you don't affect their position or their velocity while they're on the platform, they will just slide right off. Alright, so in our start method here, we are going to get some initial values. Okay, perfect. That's the calculated goal position. And we're going to set the previous position. So now in update, we are going to figure out our motion. So we're going to use the ping pong function, which does exist, to get smooth back and forth motion. Perfect. So now we're going to interpolate between our position and the start goal using this T for time. Perfect. So we calculate our new current position and then we just set it. So now we're going to calculate the velocity that the platform will have, and we're going to apply that to the player. Perfect, so that finds the platform velocity. Now we just need to apply it. So this gets their current velocity. We're going to set it to the platform velocity and then just set the velocity back. Perfect. And then we just need to set whatever the previous position was. Perfect. So now we need to figure out if the player is on the platform or not. And we can do this with on collision enter and on collision exit. So this function here is a pre-made Unity function that will automatically be called whenever something collides with this collider, in this case the platform. So first check is the other thing the player? So this line here should look familiar. Instead of getting it on itself, it gets the other collider, and it gets the rigid body of that. So this gets the player's rigid body. So now we just need to detect when the player leaves the collision. So we can copy this, paste it down here, go into enter, place that with exit. This stays the same, except now we need to get rid of this part. What this does is this says if the exiting collider is the player rigid body, then set the player rigid body to null. Perfect. This script should be done now. Let's go into Unity. No errors, please. Perfect, and there's no errors. So we are going to put the platform controller script onto here. Let's have this one just move side to side. So let's have it move 5 to the right over the course of 2 seconds. And let's see if it works. And look at that. That is a moving platform that'll bounce between 2 points. But notice how the player is sliding right now? That is because we haven't set the player's tag to be the player. So go back to your player, go up here in the inspector to tag, select player. And if we start again, the player should move back and forth with the platform. And there it is, players moving back and forth with the platform. Perfect. So now we need to add one more thing. So in order to win the game, the player needs some sort of goal. So let's just make really quick 2D object, sprite. Let's make it, let's stick to the square. Let's just call this win. Go over here, make it a color. I'm going to go with yellow, and I'm going to put this just right here. We don't need to worry about it interacting with the platform for now. Add component, a box collider 2D. Make sure this one is a trigger. That means the player can pass in and out of it, and it'll detect when that happens, but it won't actually stop the player. So we're going to create a new script, mono behavior script. Call this collision event. This is a very general script. Use these when you're making a game. Unity events are awesome. Okay, so using so this right here is using Unity Engine .events. This is a pretty powerful little thing that Unity gives you, and it allows you to have multiple game objects talk to each other without having any predefined behaviors. So you can define them as you go. It's really cool. Okay, so this is the Unity event that will be called with collision. And this is the tag that the collision will look for. It doesn't necessarily need to be player, which is why we made it a serialized field. But in general, it's probably going to be the player. Perfect. So now, if you guys remember, we're going to make another on collision enter 2D. Perfect. So now we just need to test, is the other object the player? Perfect. Then we need to just call a collision event dot invoke. Bam. So that's for collisions. That's for when two physical things smash against each other. But remember, we set the other one, we set this to be a trigger for the win event. So we can repaste this, but instead of collision, now we're going to use on trigger enter. And this is a little different. Instead of using a collision, it uses a collider, since no collision technically happens. And we could just reduce that. Perfect. This should work now. If we go into Unity again, it'll compile, and there will be 0 errors. Fingers crossed. Perfect. No errors. So if we select our win object here, and we put our collision event on it, you see this right here, this list is empty item. What we can do is we can have it call public functions on other things. For now, I'm just going to have it set win to be not active, so it looks like you collected. So you can see I just dragged win from over here down into here, and then I select game object set active. This little Boolean checkbox, set active false, and the collide tag that it's looking for is player. If I set that to something else, it won't detect collision with the player. But now, if we run it, when I run into the win box, it should turn itself off in a form being collected or achieved. You can add more events here, but for now we're just going to stick to the simple one. Bam! There it is. Beautiful. Okay, so last issue here. To fix the bug where the player is able to push against the side of something and stick to it, we are going to just right-click in here, create a new folder, call this materials, go into it, right-click, create 2D, physics material 2D, call it slippery, and you're just going to turn your friction down to 0. Go onto your player, and in your rigid body here, you'll see there's a space for the material. Drop in the slippery material, and that'll fix the bug. Alright, and just one more thing, general organization. It's good to stay organized. I'm going to move the Cinemachine camera to be right next to the main camera and the Global Light 2D. I'm going to move my game manager also to the top here. Generally, I like to organize it so that the things that don't move and are necessary for the system are at the top, and the things that will move are here at the bottom. So now I'm going to create an empty, and let's call this terrain. We can put both floor, floor 1, and moving floor all into the terrain game object as children, and now we can just hide them away when we don't want to see them. We can create a new one called collectibles, and we can just put the win object into there, and then if we add any more collectibles, we could just put them into there. And that's just a good way to manage your scenes so that you don't get overwhelmed by all the things that are there. Perfect.
All of the basic level design platforms, the character, and the character movement that we did before. Now it's time to create some enemies, some sort of challenge for the player to work with. So we'll start by creating an empty object. We'll just title it enemies. And then from here, we'll create a 2D object. Let's just make it a square for simplicity's sake. That we call an enemy. Change its color. If we're going classic Mario, let's go sort of brownish color. A little darker. Sure, that'll work. And then we'll want to move it so it's not right on top of our player. We'll just set it down right over here someplace. So now we have an object for an enemy. We're going to want to add a rigid body to this, just so that it actually can interact with the other objects in the environment. And also we'll need a collider, class collider. Also make sure that you turn this into kinematic, because we're kind of just going to make these guys go back and forth. We're not going to want them to be doing any sort of physics that would need to be dynamic. So it's simpler to just leave it as kinematic, unless it's needed to change later for a more complex enemy. We've added our box collider, we've added a rigid body, so at this point now it can interact with the environment. So if we were to run it here, it can interact with it, run into it. Basically, we have the starting point for our enemy. Having a enemy is a great starting point, but it's kind of boring when it's just sitting there, right? So we probably want to add some movement. And luckily, we kind of already did this when we made this moving platform. If we look at it, we've already set up the base idea of movements on a controlled environment coming from one place to another, which is a good starting point for our enemy, right? We don't really want complex movements right now because we're just doing a minimum viable product. So we'll just reuse this sort of moving platform behavior for the enemy for the moment. So if we go into our enemy object here and we add a component, we can just add the script for the moving platform. And then we need to set a goal, so where it's going between, obviously. So let's see, let's just set this little enemy guy up towards the edge over here. And see if that's set at 765, and we want it to move all the way over here, let's say, which is 16. So rough math, that's going to be about 8.5, let's say, and we can modify that as we go. Just put it at 8.5, and then movement time. This is just going to determine how quickly it's going to move. Let's just set it at 3 for the moment. We'll see if that's too fast or too slow. If we run it, should see the guy moving if you've done everything correct. Yeah, so as we can see here, it's just moving back and forth along this. It seems like that's like roughly the right distance that we want. We might want to make it a little shorter, a little longer, but that can be decided with pretty easy changes down here, just changing how far horizontally it's going and where we want it to actually start. So now that we have some movement with this enemy, let's create something that's actually going to happen when that character interacts with the enemy. Probably the simplest thing that you want to happen when a player comes in contact with an enemy and it's not good would be that the player is hurt, right? So let's add a hurt functionality inside of our player controls. So we can go down to the bottom here. Underneath all this, we'll just make a new like the void function that we'll call hurt. And we just kind of want this to physically damage or affect the player in some way. For the moment, let's have it just change the color of the character so that we know that the character has been hurt. So we can do that. Just doing a get component. Sprite render. So change color to red. That would be red. And then we'll add a debugging log just so that we know for sure that it's interacting, like just kind of a little message. And we'll start with that. Obviously, we need a way to actually call this hurt function when it interacts with it. So we're going to go back into the enemy and we're going to add a component. We're going to add a collision event because we already created a collision event that can call that particular function. So we go into this collision script. We can add a runtime only event here. For the object, we're going to make it the player so we can get the function from the player, controller right here, and part we want to list hard. And the tag should be player because that's what our player is labeled as. So if we run this, hopefully, we should see that the player can now run into Sprite and the color will change. Let's say we now wanted to make an element to destroy or defeat our enemy that we've made. For the classic platformer, we can just have this be the player jumping on top of the enemy to destroy it, or squash it, or stomp it. So to do that, let's start by creating an empty object under our player. We can just call this object Stomper. Probably also want to tag it as Stomp so that we can find this later. So just add a quick one here. Let me add it. There it goes. Stomp. We'll go into our Stomper element here, and we will tag it as Stomp. So basically, this Stomp element we've created, we just want it to be an element that's going to exist below the player that will allow it to interact and stomp other objects. So we're going to need to add a box collider for that. We also want to set the stage trigger because we don't want this box to actually collide with objects and have it like bounce off of it or anything. We just kind of wanted to acknowledge that an object has caused a collision. So that's what is triggered will allow us to do. Also kind of want to reset this sizing. So let's see, let's just, it's bigger. Let's set it about there. Maybe that. Get something like that size, and then we'll just move it down. Let's just guesstimate this right about there on the feet, and then we just want to center it in the object. And this will just kind of act as our little stomper right below our character. This can obviously be resized, and how big you want it and where you want it located on your character can change, but this is just where I'm going to set it up for this particular demonstration. So now that we have this object, it can act as a stomping mechanism. We actually want a collision so that it can interact with our enemy and actually do the stomp. Basically, when the enemy collides with this box, we just want the enemy to go away. And a really easy way to do that is just to deactivate it within the hierarchy. So we're going to go into our enemy here, and we're going to add a new collision script. We want to make sure that the collide tag thing that it's looking for is stomp. And then we'll add a new collision event, keep it at runtime, make the object the actual enemy. And then the function that we want, we have an action from GameObject that is like the setActive function, and that's going to be what we're going to want to use here to have it basically just remove it, so the object can't be interacted with on the actual scene. So if we go in here and we go into GameObject, right at the bottom here they have the setActive bool, and so this will just, anytime that the enemy comes in contact with the stomp tag, which is attached to a stomper, it will set this bool to false, and the object will just shut off with the hierarchy and it will not work, and so it'll just disappear from the scene. So if we were to run this, let it compile everything. Slowly. Run this, and come over to this game thing and jump right on top of it, Stomper. Boom. It disappears just like that, and our enemy is vanquished. So at this point, the enemy looks pretty good, right? We don't have a whole lot happening with the character when it interacts with this enemy. Our enemy's disappearing, is getting squashed, but the player, they basically just turn red and tell us that they've been hurt, which is not particularly exciting, especially for a video game where they're not even going to be seeing the console little debug codes that we are putting out to tell them they're hurt. So let's actually add some stakes to this, right? Let's add some health and some damage features. So let's start that by going into our scripts and player control. So this should be pretty simple to add some health features. We'll go into our private variables and let's just add one that we will call, we'll make a private float that we call health amount. Basically, we'll just want this to tell us like how much health the person has, and let's just set it equal to 100 for the moment. Also create one private float that will put damage. That will just set, let's be pretty brutal about this. Let's just set it to 50 right now. So now that we have those, these are the stats that are going to kind of determine the health. Note here so that we know which are exactly. We have our health stats. They're not really doing anything at this moment, so we need to actually add some function to change those stats. So let's go down to the bottom, right down here, and we can make a new function. Let's call this one take damage. We'll give it an argument. Let's give it a damage. So this will allow us to go in there and change how much damage the player takes if we want to have different scenarios or different enemies that might cause different amounts of damage. For now, it's just going to be 50, but we can have inside this function the health amount decrease, obviously. So the decrease by the amount of damage have listed, and we want to make sure that the health is actually being capped at 0 and 100 because we obviously don't want the health to get above 100. That doesn't make any sense if our health max was 100 to begin with, and we also don't want it to get below 0 because then we're going into negatives, and that also doesn't make a lot of sense for gameplay purposes. Once you hit 0, you should be dead, right? So we will cap this health, and the simple way to do that is just with a quick little function that's built in. So if we set amount equal to math clamp, then we can set the amount as what we're capping, set the minimum 0 and the maximum as 100. Just cap that for us. And then let's say that we want to have some sort of, for fun, some sort of damage that causes an unpleasant effect. So let's say when you get damaged, you get slowed down. You can pretty easily do that by just modifying max speed stat that we had. And we'll decrease it to 7F. Just as a test run for now, if we feel like that's not punishment enough, we can increase this, but just slow the player down a little bit because they've been injured. We will save that as it is. And now that we have this, that we need to actually implement it. We need to make sure that when a player is hurt, they actually take the damage. So let's add that right in here. We'll just have the hurt function call the take damage function. Take a normal amount of damage. And let's just do a quick debug statement here so that we can see that it's actually decreasing our health as we expect it to. Let's health out here. And that's before we call the damage function, and we'll call it here at the end of it so that we know how much it's taken. that should be all that we need to change for the moment, so let's save that. Let's increase this. Should be able to run it now. Hopefully we'll be able to start it up here. It's running. Jump up here and just wait for it to hit us. We should fix that in just a moment. But if we look at our log here, we see that the player's hurt. Health goes down from 100 to 250. So now that that's working properly. Stop this. We should fix that collision really quickly, though. If we go into this collision event script that we have, we can pretty easily fix this if we just add something right here for this collision on collision event. We essentially just want to have that factor where it turns off the game object if it collides. We want that turned on here as well. So we can just add that here. Set it to false. So this will just manually do what we were doing earlier with the Stomper, where if the enemy object or whatever else we set with this collision events, if it collides with something, it's going to call the function that is placed in it, and then it's going to now set this game object to set active to false, so that it'll turn off the enemy, so the enemy will disappear after our character runs into it, instead of kind of that thing where it's colliding with it and continually pressing against it. So if we save that really quickly, that should stop that weird collision we were seeing just a moment ago. So run that again. Should hopefully see that when we put our character here, it collides there. Yeah, it just disappears now. So that's that. So since we're in health, wouldn't it be fun to create a little health bar for our game? We can do this a few different ways, but the simplest one for now will be to create a canvas that's going to hold the health bar just as like an image on the page or on the scene. So let's start doing this by making a canvas. So we can right click, go into UI, go down to canvas. We will just call this canvas health bar. We'll want to set it so that the scale mode is scaling the screen, and set the resolution to 1920, 80, just as a general reference resolution. This is just going to help so that it always scales to the size that we want for the screen, so that this little bar doesn't end up all over the place on different screens. So now that we have a basic canvas, let's add under it an image that we'll just call health board. Well, just sort of as a block that's going to act as a border around the actual health bar that we make. We want to actually set this source image to a rectangular sprite. We can do this if we just go into Sprite, Editor, Object Menu, Textures, right here, this square one. Very long way to get to it. But if we go into our health border, we can just drag that square top of it. So now we have a square source image to it. At this point, let's make sure that the color is black, because it's just going to be our border. And then let's set up where it is. We want to make this longer rather than taller, so we'll set this height to 20. You want to make sure these anchors actually anchor from the right-hand corner of our canvas. So we'll set these to 1. And actually, this canvas is like huge compared to our scene. So we zoom out, we can see where it's trying to make this canvas. This looks really big in the scene, but it doesn't look the same once we actually import it into the game, and when it gets run on the game, it won't look like this. This is just part of the way that it functions inside of a scene. We don't really want it centered like this though, right? So if we're looking at this as the whole screen, we want this to be in that little corner over there. So let's drag it up there. Kind of looking for it to be maybe like 100 off from the side and maybe like 50 from the top. We'll just make that, and that's going to be our little health bar up there in the corner. This is just the border, so we want to actually duplicate this health border, and we're going to call this image health, and we will make the color red to indicate that this is damaged, right? I mean, like, we want to make that a little bit smaller, so let's just go down by, like, we'll go down by 10, so make it 90, and 10. And there we go, we got a nice little red bar for our health there now, right? And then we want to do this again. Duplicate and damaged health. And we're going to call that one. Let's call it total health for now. Like a green to indicate it was like the good health. This is the positive. We want it to be exactly the same size as the red, so it's just covering it up. And actually, when we go into this raycast part, we want the image type. We want it to be filled. So not raycast underneath it, sorry. In the image type, we want it to be filled, and we want it to go horizontal so that it fills from left to right. And what this is basically going to do is it's just going to allow us to move this health scale so we can have an actual health point that scales and moves depending on how we want it to. So this is just like the basic UI part of the scene. Now we actually have to go into the code to make it work. So if we go into our scripts and our code again, we can actually just add right up here in our health section. Let's just add. So if we take a look back into our code, we can go in here and add a public image that we will call health bar. So this is just going to connect to that UI that we've made. And specifically, we're going to want this to connect to that green bar that we made that has a fill amount to it. So then we can go down into the take damage function, and we can have the damage be demonstrated by moving the green bar down, so lessening the fill amount, so that the red shows up behind it and indicates that you've taken damage. So if we do a line like health bar fill amount, so what's your the health amount you have divided by 100 to indicate that, or to scale for the fact that it's between 0 and 1, then the health bar fill amount should move to 0.5 when you take that 50 damage that we currently have set. And so it will look like half of the bar is red, half the bar is green. So we'll save that. We'll go back in here. We do want to make sure that when we go into player, you now have a section, where's it there? Image, that we need to actually add this total health to. So now that we have that set up, if we go into play, let's load up. Should be able to jump over here. You can see the bar in the top corner, and if we get hit, we see that it takes that bar up in the corner and divides it in half. So the fill amount of the green is now at that 50% mark that we're looking for. To a sort of adjacent topic. Now that we have a way for a character to be injured by running into our enemies, we need a way for them to die, right? So there are plenty of methods for doing this, but one of the easiest ways that we can do it is just to create a great game over screen that will appear whenever a player takes too much damage or meets some other requirement that equates to death or game over. If we were planning to have more intricate concepts for what death is, or to have that be incorporated into the finite state machine, which will be talked about later, then we would want to actually have death be a state that we can set. But for this basic project, we're just going to create a game over screen so that we know that the character has failed, then they're dead. So, to do this, let's start. Let's make a new canvas. Same as before, UI canvas, and we'll call this one game over screen. So, we want to scale this one the same as before. Make it scale with the screen size. We'll set it to 1920. That's 80. What we're going to do a little different here is we're going to add a component that is a canvas group. So what this canvas group is going to do is just control what layer is visible and invisible, like if we can actually see this canvas layer or not via this alpha variable here. So we can set it to 0 by default when we're not like wanting to do any work on it. For now, I'm going to leave it on as 1 just so that we can see what's happening. But we'll set this one to 0 before we actually run anything. So under canvas, under our new canvas, we're going to create a image just like before. We'll call this one just black background because that's all we're going to have it really. Set it to black. You don't really need to set a sprite to this one because it's not doing anything complex. It's just going to be a large black screen. We want it to fill the whole thing, so we're going to actually set minimums to 0 and maximums to 1, and this will put us into stretch. So if you put 0 for the various variables, left, top, right, and bottom, it won't stretch it at all, and so the entire canvas will just be one big black background, which is what we're looking for at this moment. And then we're going to want to also add some text. Text will just have to say game over, so let the player know the game is over. We'll make the text red to make it really stand out here, and we'll change the size to something like 100. And then I'm just going to zoom out so that we can actually see what this looks like here. You might want to resize this text box. If I could accommodate the size for our game over, we will set this to be right in the center. And we'll just want to this will cooperate with me. Just resize this so that it fits the game pretty well. You might want to make this a little bit bigger, or just generally try to size it so that it comes from the middle. There's some big text. Let's resize this however you would like, just to get the words on the canvas wherever you want. Not super important, just for the aesthetic of it more than anything. So, move it here so we feel like it's about where we want it. I'll leave it there for now, so we don't spend too much time on that. We'll go back in here. Forgot to label this one, but we'll just call this game over text. With that, should be able to just go in here, set this to 0, and this is our basic canvas with this game over screen that we're looking for. So now we have our end screen, we need to implement it into the code. So we got to go back into our code to do that. Back in our code, we just need to actually set this implementation. And so we're going to start by going right over here again. We're going to make the section for game over. Make a public canvas group that we can call game for canvas. Let's have that set. not really need to do anything else with that for the moment, and we will move on to creating a function that will actually cause this game over. Make this a public void game over function. Then we can set all of the parts of the canvas to true. So, or 1f in alpha's case. Set the interactable to true. And set the game maker as true. And these are just making sure that the game over screen is actually visible over everything else on our screen, so we won't see anything except this particular screen. And so this is just the basic game over function that we need. Doesn't really matter, I guess. Either way, after that, we actually just need to have it called in update. So if we go up to update, we want to create a quick if statement that just checks if the player's health is 0. So if our health amount is less than or equal to 0, then you want to call game. So this should be pretty simple. It should just check if the health amount is less than or equal to 0, which would be if a person ran into 2 different enemies. We don't have 2 on right now. Let's say we did. If they hit 2 enemies, then game over. So, save that. This is just very basic game over functionality, just to give us death or failure notice. And after this, we can create an ability to restart the game from the beginning and a simple method for like a BC mode if we wanted to. But for now, we're just making this. So let's also add a new enemy. Let's duplicate one, and we'll set up that enemy over here. Just so that we have 2 enemies, so that we can test this running into 2 enemies thing to make sure that we are getting the strength we want. So, actually, before we test this, we need to really quickly go into our player. And right here, we have this canvas group. We just need to add the game over screen into our canvas group, so it knows what it's doing there. Now we call it. We should be able to just go up here, let this guy run into us, take the damage. You can kind of see this slower movement here when we reduce the max speed. Go over here, jump on this platform, let this guy hit us, and we get this big game over screen to indicate your game's done, you died, and your health is at 0 up in that corner. At this point, we have nearly all the functionalities we could want from enemies, damage, and death. So this combined with all the rest of it should have given you most of the elements that you need for a basic video game. One of the last points we need to consider is if someone misses a jump and just like plummets to their death. So we need a fall threshold so they don't just fall forever and the game never ends. This can be set up in the code at the initialization, and then we'll have a check later that sees if the character's position is at or below this threshold that we set, and if it is, then it calls for that game for function that we made. So if we just go into our code again, and we go up to the top, we can set this, we'll just set it up here with all these other ones that we have. We'll make another serialized view. Float. And we call this one all threshold. So this will equal to -10 for now. Then we just need to go in to our update function here and have an additional check. So We want to call game over not only if the health is equal to 0, but also if the transform position is less than the fall threshold. So the position that the character is at is below our fall threshold. Then we want to call this game over. If you wanted to add additional options or complexities for different like options for what happens other than game over, we could also have that just by including a starting position. So it would just like after the fall, it just resets you back to where you started the game at. So to do that, we could go into these variables, create a private vector2 that we call starting position. And then inside of start, haven't been adding a lot of things here. From here, we can put starting position equal to, let's say it's already guessed what I want, transform position. And so this would have it be the starting position right when it first starts up, and it wouldn't false again. So this would always reset to the same place. Okay. Forgot underscore there. Perfect there. And so then we would need to create, in that case, a alternative reset function, because then we would want it to go right here and call some reset to start function. We could build that reset to start function down at the bottom with everything else. We made a void reset to start. We just have this one take the position and set it to that starting position. That's all we really need just to do to reset that character to its first position. But we also probably want to include this line here, which is just setting velocities to 0 so that we don't have any momentum that might have the character fly off and then die again. That just prevents that from possibly happening. And so then we have that reset to start that we could have in place of this game over, depending on which one you wanted. Just pick one or the other, because they obviously won't both work together. If you want a simpler thing, like this will just set the character back to the beginning of the screen. If you wanted to completely reset the entire scene, we could do this. And this line basically will just reset everything, the health bar, the characters, and the location of the character, and the enemies, everything. Everything gets reset because the scene just reloads itself. So that's a really quick way to also just reset your game and have an ending other than just game over. So these elements should just give you a jumping off point, somewhere to start with your game. Obviously, you need to develop this further, add new things, improve on it. There's a lot of things that we didn't do here or that could be done better, but this is just for your minimum viable product. So obviously we want to add from here, but this should give you a starting point. So if we save this and close that out, try and load our game one final time here. So you should be able to run into this one, take some damage, be slowed down a little bit by this, but we can come in here. Come up here, let's just jump on top of this guy, stomp him. And now we'll just fall off here. So as we're falling, it triggers a game over. So this tells us that all the functionalities are working. The basic game is here, and we could build from this.
Hello. I will be instructing you on how to add a main menu, pause menu, and game over menu to your game in Unity. We will be starting with the pause menu, but before we really get into it, it's kind of important that you check your key bindings. Like make sure you know which key you want to use to bring open your pause menu. I imagine some of you might have your application.quit function bound to escape, and so if you plan on using escape as your pause menu button, it's best to rebind that to something else. I have it bound to Q here. Now that we have kind of just that out of the way, we can move on to actually creating the pause menu itself. So over here in the hierarchy, press right-click, go down here to UI, and then do Canvas. Now note here how this event system object was created when I created the canvas. This is important. If you ever want to copy this canvas into other scenes, you must copy the event system with it. Otherwise, the canvas will not function. I will name this to canvas pause menu. And then within this canvas, I will go down to UI and create a panel and rename this to pause panel. Before we continue though, probably important to check out the canvas scaler. I'd recommend changing it from constant pixel size to scale with screen size. And then I'm going to change my reference resolution to 1900 by 800. You don't have to do this. It's really bit down to personal preference. But then within this pause panel, kind of getting back to that, I'm going to go into UI and then text mesh pro, and then in this text box, I'm just going to type in paused. It's just something that I'll put at the top of the screen. So I guess I may as well give a reference for it. Just put it at the top here. It's paused. We're in a pause menu, so it's good to know that you are paused. Within this text box, you can change its font size, the font itself, whether it's bolded, italicized. I'm not going to mess with that. You guys have fun with that. I'm just going to change alignment, center, middle. Okay. Now we're going to create the buttons we need for our pause menu. So once again, go to the pause panel, UI, and then button. Then what I'm going to do is I'm going to press Control D to duplicate twice to create two other buttons. This first button will be our resume button. The second one will be main menu. And then the last one will be quit button. I should probably change this to main menu button. Okay. Now within these buttons, just the button elements themselves, what you can do is you can change the color of the button, what color it shows when it's highlighted, when it's pressed. I'm going to change these, so I'm going to make this just a red. You don't have to, but it's probably a good idea. This is blue. This green. And then each of these button elements has its own little text box that you can edit. So I'm going to do that for each of them. Makes it so that you can distinguish them on the screen. And quit. Then once this is done, resume button, just move them on the screen so that way they don't overlap. Now, while we've created these buttons don't actually function. Not to mention, if we were to go ahead and play it, it should just have, the pause menu right there. We go over the buttons and they don't really do anything. So what we need is a special script to manage this. So I will go here, create monobehavior script, and rename this to pause manager. This is how we'll give functionality to our buttons, as well as making it so that the pause screen isn't just visible when we open the game. We want to be able to toggle the pause screen on and off. Now, in order to do that, we're going to need 4 functions. We're going to want public void, resume game, we are going to want a function to pause the game, we are going to want a function to bring us to the main menu, though we'll be tackling it later when we actually create the main menu. And then we are going to want a function to quit game. Cool. Now we head back to the top here. There's a few variables that we need to create to manage all of this. We need a game object named pause menu. Then a public static bool named isPaused. IsPaused is how you tell whether the game is or is not paused. If isPaused is set to true, that means that the game is paused, and vice versa for false. Now we can go to our start functions. We'll want the pause menu to be to not be visible. So we'll want pause menu dot set active to false. This is just on game startup. And then for update, what we're going to use the update function for is checking to see if the escape key is being pressed for bringing up the pause menu. So we're going to want an if statement if input dot get key key code dot escape. And then within this if function, we'll want another one. So if is paused. If it is paused, we'll want to call resume game, because the escape key will serve to toggle it on and off. Else, whoops, pause game. Okay. Now we can actually get to our functions. Like I said, we're not going to be messing around with the main menu function until we actually create the main menu. So for now, we just need to focus on resume game, pause game, and quit game. Pause game and resume game, they're just mirrors of each other, so they're going to look very, very similar. So pause menu dot set active false for resume game. Then we're going to want to do time dot time scale equals 0, and then is paused equals false. Then within the pause game is pretty much the opposite, so we can just copy this, Control C, Control V, change this to true, true, and then set this to 1. Or no, I got these mixed up. Set this to 0 and set this to 1. The time.timescale will pause game if set to 0. If set to 0, so that means that the enemies and you will not move around. Now we've got this set up. Head back into the editor. Wait for it to reload. And now we can start attaching this pause manager to some of the important assets within our hierarchy. So what we'll want to do is we'll want to start by heading to this player object and drag our pause manager into here, add component. And then in here in this pause menu, we'll want to drag the pause panel right there. Then, hold on. What we'll want to do is we'll want to go down to these buttons. So look here at this on click. What we will do is add to the list, pull in player, and then in here we'll go to pause manager and resume game. Then do the same for the main menu and quit buttons. Like I said, the main menu button is not going to do anything for now. We'll get that set up later. But main menu button, hold on. Add to the on click. Add the player. Function, pause manager, main menu. Quit button. Whoops. Dragon player. Function, pause manager, quit game. Now what we can do is give this a little test. So press play. Okay, so now we're in the game. Let's press escape. Oh, that flickers a little. That'll be fine. Quit will not work within the editor. We'll have to build and run for it to work. But resume seems to work. The flicker, I think I have an idea of what's causing that. So head back over here. Get key down. Yeah, that's probably what's causing the issue. It should be. Now let's load it in. Move around. Escape. Resume. Main menu. Quit. Hit resume. And it works. Okay. Now we want to get started with the main menu. So in order to do that, we'll need to create a new screen. I've already created a new main menu scene here. However, you can do it by going into just right click, create, and go to scene. Let's switch over to the main menu now. Okay. This will be the menu that your game opens up to. So for that, we're going to need another canvas. So that will be down here. We'll name this to, I don't know, main menu, or hold on, canvas main menu. There we go. Then under this, we don't necessarily need to create a panel. We can. May as well. We can change the background. We can change the color as well in this. I'm going to, I don't know. White sounds nice. And then within this panel, we can create more buttons. So we're going to want 2 buttons for this one. We're going to want a play button, and we're going to want a quit button. So rename play button. Then rename this to quit button MM for main menu. Play and quit. And once again, these buttons don't really have much in the way of functionality like we would like them to have. And so for this, we are going to create a separate script. We could technically use the pause manager, but I want a script that can be used specifically for creating screen transitions. So what I'm going to do is change scene is what I'm going to name this, and then open it up in my text editor. This script is going to be very simple. We don't even need the start and update. All we need is, first off, using Unity engine dot scene management. There we go. Then we're only going to need 2 functions for this. Public void move to scene. And then public void quit. Oh, whoops. No. Just needs to be quit. This is going to be the exact same as our other quit function, application dot quit. I may as well rename it to quit mm, just mm for main menu. And then within move to scene, what we want to do is for parameters, we want an int scene ID. And then within the function itself, we want to call scene manager dot load scene ID. Really, these are the only functions that we need for the main menu. So check. Okay, saved. Let's head to the editor. Okay, now in here, we're going to want to create, I guess, just an empty object. We are going to be using this as a main menu manager. Now, within this main menu manager, we are going to want to add, hold on, the change scene, just that it has it, and then we can add quit button on click. There we go. We can add the main menu manager to the on click for the quit and play buttons. So for this, we want the hold on. Main menu manager, change scene. Back to the quit button. What you need to remember is that you forgot to place down a semicolon, and for whatever reason, that just screwed everything up. So, Yeah. Anyways, where were we? On click, we have the main menu manager. Now we need to apply a function to it. So quit. And then for the play button, we're going to want change scene, move to scene. As you can see here, there's an input box down here that we can put a number into. We are going to want to put in the scene number for the main game itself. However, if we take a look at build profiles, we have a scene's main menu here that is 1. However, we want this scene to be loaded in as scene 0. So within the scene list, all we need to do is drag sample scene just right here. That makes the main menu to scene 0. Let's see. Okay. And then within the play button, we will change this to 1. So let's play and see if this works. Click play, and it takes us to our game. Amazing. Oh, but yeah, we'll get to this in a bit. But anyways, let's just say you want to make your main menu screen not look terrible. Let's just, I don't know, let's add an image to it. 2D UI image. And we take source image, and let's just use this image. I like this image. This is the image for our game. And then maybe we want to add in the title, in which case, I guess. And we just call it game. Congratulations! We now have a main menu and a pause menu. However, as you saw earlier when we died in that game over screen, there's not really a whole lot to do in that screen. So what we are going to do is we will be creating a new scene. Create scene. And we are going to rename this to Game Over. The Game Over scene it's going to be fairly similar to our main menu. So what we are going to do is we are going to create another canvas. I'll just leave it named as canvas. Then I will create a panel. Game over. Yep. Add some text. Say game over to just really drive the point home that this is indeed the game over screen. And then we create 2 buttons for this, or at least I will create 2 buttons for this. So Control D. The first one will be the restart button. And this will be main menu geo for game over. Main menu on this one. And then label this one as restart. Then finally in the hierarchy, we're going to want to create an empty object named, I guess, Geo Manager, Game Over Manager. this game over manager, we are going to want to pull the change change scene into right over here. And this will be used fairly similarly to the main menu manager. Let's just pull these. Now we may as well get our buttons set up. So restart button. Drag in our game over manager. Then we go to change scene. This is restart. So we do move to scene 1. And then for the main menu, we will want to go to scene 0. Now all we should need to do is make some final additions to our script. So I said earlier we need to go to the pause manager. Wait, I forgot to get the quit game. Oh well, this is just application.quit, as I had done in the change scene. And then the main menu. That is time.time scale equals to 1.0f, just to make sure that time can run again. And then we'll want to call scene manager dot load scene 0. We already have unity.scene management up here. Good. Then we need to move over here. Oh, after saving, we need to move over here to the player controller. Now, this player controller has a trigger game over that we are going to want to edit. One sec. So this trigger game over is what created the previous game over scene, and we just want to either comment it out or remove it entirely. I'm going to comment it out, and I am going to call scene manager dot load scene, and we're going to call 2. Now, probably should make sure, yes, it does have unity.scene management, and we should be good to go. Let's go to scenes, go to main menu, save changes, and let's play our game. Play. It does pause, it resumes. We can go back to the main menu, play again. And then very quickly run to the end. Relatively quickly. Or actually, fall off here. Oh no, we messed something up. Something didn't work right because it didn't go to game over. I think I have an idea why. Yeah, it's because I didn't add the game over scene, probably. There we go. Okay, now we check and see if the game over works correctly. Okay. Game over. Head back to main menu. We can play. And there we go. You now have, hopefully, a pause menu, a main menu, and a game over menu. Thank you for watching, and I will now pass it on to the next person.
Hi gamers, I'm Jillian. In this section I will show you how to make a simple Boolean toggle in the user interface. Since all groups are required to have a BC mode for their games, the walkthrough will be based on achieving that. Alright, so far we have the base game and the essential menus. You can have a settings page accessed from the main menu or the pause menu, but for simplicity, let's just create the toggle on main menu. Alright, so make sure you're on the main menu scene, wherever you are, make sure you're there. Let's right click on the parent canvas, go to UI and select text, call this BC, and let's scooch that over. I'm going to put it on the right here, but you can put it wherever you'd like. This will just be a simple title for the toggle. I'm going to size that up to 45. And I'm going to go to game view. Yeah, that looks decent. Might scooch it over a little though. Alright. Next, go ahead and right click again. UI, click on toggle. Name it, and it's really tiny, so let's bring that over here as well. Alright, it does automatically come with a label to the right of it, but I kind of like the look of having it up top in this case. I'm just going to delete that, but you can keep it if you'd like, and you just type in text in there. Let's see here. I'm going to hold down the shift key and select both the check mark in the background, and let's size it up. Probably right there is good. And I'm going to resize the check mark. I'm just going to go to the position X and just center it with 0. Game view. It's a little off center, but woo. And voila. Now it is set up in the user interface. Let's go to game. I'm going to view the console here. Unity's gonna think for a second. Okay. So as you can see, there is visual feedback for when I click on and off the check mark. You can also see it in the inspector of saying is on or not. Click play and get hit by an enemy, and you still take damage, which makes sense because we need to make the script to have the toggle actually do something. So let's go to scripts, create, scripting, mono behavior, name it something so everyone knows what it is. Open up your preferred editor. Now for time constraints, I'm just going to copy what I've already written, but basically I got rid of the update function that was already there, renamed the class, and put most of the stuff in the start as well as make an essential function here. Let me just kind of briefly walk through what this does. Okay, so this field right here allows us to assign the toggle component in the Unity inspector. And here we need to check if the toggle component is assigned. If it's not, try to get it from the current game object. If it's still not found, probably log the error and exit the method. Down here is the function, and it's going to load the saved BC mode state from player prefs. And what the getInt does, it returns 0 if the key doesn't exist, so we compare it with 1 to get the bool. This is pretty important because it allows BC mode to persist between different game sessions when it's set. Let's see. This one is to set the toggle without triggering the onValue changed event down here. This makes sure we don't save the state unnecessarily on startup. And then, of course, we have to add a listener to the toggle's onValue changed event. So we'd call this whenever the toggle is changed by the user, which is a function right here. Okay, we'll save that, go back to your editor, and Unity is going to compile it. Let's go to the toggle we made here. And we're going to drag that script to the parent toggle object we made. And there's the field we made. Yeah. And then we're going to drag the object again here because we need, whenever the user is going to click the checkbox, we need it to sync up properly with the script. Otherwise, it'll be out of sync. So yeah, we need that to sync up. Okay. We're going to test that. Okay, by default, it's false, as we defined in actually another script, which we'll pull up soon. But in the console, you can see that it is being turned to false or true, which is what we want. Let's say it's true. We still take damage. What now? Well, gotta go to that other script. Where is the player getting hurt? Well, let's open that script up and take a look. Looks like the minimum viable product people were already thinking ahead. I'm just gonna, yeah, so this is where it's like, oh yeah, it's false by default. We are going to make a new function. Let's see. Let me ponder about this for a second. Let's do a private. It's going to refer back to that bool. Let's think here. Player preps, by the way, is a Unity class that gives a simple way to store and retrieve small amounts of data between game sessions. So we'd want it to like the toggle to be preserved, like data persistence between different scenes and sessions. So it's not like isolated to one scene. So it's like a nice Unity thing here. It's not for like extensive game progress, but just really small values, which comes in handy sometimes. I think that's probably all we need in that function. Yeah, so it would basically synchronize the local BC mode bool variable with the BC mode state stored in player preps. So this would retrieve the integer value saved there, and if it doesn't exist, it'll just return 0. Then it'll compare the retrieved value to 1 and result this comparison like true or false. And then it would assign it to the BC mode variable here in this file. Of course, Visual Studio doesn't like it right now because I haven't called it. Oh, here is the take damage function. So let's say if it's not, so if you're in default mode, then you'll take damage. And it's red here. I think that's the visual feedback. So we'll say it's not BC mode. And good. I'm actually gonna comment this one out. Because honestly, if the player falls off the screen, they should still have, no matter what mode, the choice to go back to start or the main menu or whatever checkpoint you have set up. I'm gonna save that. Let's probably call it here. What is it? The VC mode. Yeah. So it'll constantly check for that setting. And I think that looks good. Let's go back here. No errors in the console, that's a good sign. Let's go back to game. Let's play that. Okay. That's working. Let's have it true. And now we're in God mode. Will not take damage. Fall off the screen as intended. Can be able to restart. Doesn't turn red. The health bar doesn't go down. And yeah, that's how you make a simple toggle.
Hi, my name is Isaac, and I'm going to be going over your tile map creation, how to do it, and how to do background creation. So first thing, open your Asset Store web, and then go to 2D Environments, select Free Assets in the filters, and then select the first one. This button will say Add to My Assets for you. Press that. Now go back to your project, press the Asset Store again, and then go to My Assets. In the My Assets tab, you'll see Free Platform Game Assets. Press on that, and then this should say Download. Download it, and then Import to Project. Press Import to Project, and now we wait a second. Oh, there it is. Okay. We will select what we actually want to import now. Just collapse all of these directories. We only want the backgrounds and the tiles. So everything else, unselect. You got tiles and background selected. Press import. All right, and now you'll see in your assets. Oh, by the way, this normally looks like this, probably for you guys. To make it way easier to handle all these assets, first change this to one column layout. Right click on this and change to one column layout, then drag it over here. Drag it into this section right here. Okay, now we're going to work on our tile map. So go into Free Platform Game Assets, and then Tiles, 2.5D tiles, Spring, PNG, 128 by 128. And you can see you got your dirt and your grass mid. These are two tiles that we're going to be working with. So then right click on your hierarchy, create 2D object, sprites, tile map, and then rectangular. And this creates your grid, which contains all your tile maps, and then your tile map. We're going to rename our tile map to ground, which is just going to be dirt and grass. And now we're going to create a tile palette. And to open up your tile palette to start painting with, first select one of these. Press Open Tile Palette. We're going to create a new tile palette by selecting Control Select to select both of them. Dirt and grass mid, drag them into here. Create a new folder. Call this Ground Tile Palette. Select it. Bam, you got your two dirt and grass in that tile palette folder, and you can paint with them. Just left click to paint. Then to delete, hold shift, And to paint a lot at once, hold Control, and that will copy what you just selected, and then you can paint them all. And then same thing, you can hold Shift to erase it all with that same big bounding box. And to go back to one, just select this again. Select one of these in the tile palette. All right. Now, you'll notice that it would be quite convenient if we could automatically have these ones generated as the dirt tile because they're underneath, and the ones on top would automatically be generated as grass tiles as they are right now. So to do that, we're going to create a tile rule. To enable tile rules, go to Window, Package Manager, Unity Registry, search 2D Tile Map, and then you'll see Tile Map Editor, Tile Map Extras. Press Unlock on both of these and close that window. Now, go to our ground tile palette folder that we created, right-click, Create, 2D Tiles, Rule Tile. And then we're going to set a default image for this rule tile. Right now it doesn't have one. You'll see up here it says default sprite, none. Drag your grass mid up into that, and now it kind of looks like something. So we will drag our new rule tile into our tile palette, and now we can use this tile because it's in our tile palette. You'll notice it looks exactly like our grass tile palette because we don't have any rules set up yet. So to add a rule, go to Tiling Rules, press plus, and the first one that we're going to add is grass mid because we want grass on top, and then add another one, and we will set this to dirt because we want dirt on the bottom. Let's delete what we have so far. I'm going to hold Control to make that big box, and then press Shift to delete it all. Now, if we do this again, still it's just grass. We have to set up the rule. To set up the rule, we will use these little boxes. And how this works is if it looks like a green arrow, if you put a green arrow down, that means something must be there for this to be placed. So you'll notice I can no longer place a grass block because there's nothing above it. As soon as I go underneath it though, this is okay because this says that there must be something above it to place a grass block. So I can place grass blocks now underneath things. So this is kind of reverse. You see it's backwards. So if we go like that and then like that, oh, and say there can be nothing on top actually. Whoops. Okay, so we'll just put an X up here instead. Bam. Now nothing can be on top. That's good for grass. And then dirt doesn't care. It can be anything. So there you go. You got your automatic tile generation. But an issue still is occurring. If you zoom in, you can see that these are actually overlapping, these tiles. They're not staying within their bounding boxes, these white lines. To fix that, select dirt and then select grass mid, control select both of them. Change their pixels per unit to 128, press apply. 128 because that's the size of these tile images. And look, they now fit in the boxes perfectly. Alright, so we have created our tiles. Now we'll move on to the background. To start, right-click on the hierarchy, create empty object, call this background. Inside our background, we're going to create another container and call this skies. And then also create another container, call this clouds, and then another one, call this hills. And then inside our free platform game assets, go to backgrounds. Inside backgrounds, go to backgrounds again. Inside backgrounds, go to PNG. Inside PNG, you'll see 248 by 1536. Go to that, and then all, and then sky. And you can now drag sky into your skies. And bam, you got your sky. Let's close our tile palette. We don't want to be painting tiles anymore. You'll see now that I'm like stuck in this drag mode. I accidentally pressed Q. If you press T, you can get out of that mode and back into selection mode. So we can drag this around now, and to change the size, you can drag this top one and hold Shift to maintain your aspect ratio of the image. If we drag this out like this, you'll see the image stretches. We don't want that, so go back, revert, Control Z, and then change draw mode to tiled. Now when we drag, you'll see it creates multiple images. It's kind of hard to see, but this is 2 images right here. You'll see it better if you go up. See this? It's definitely tiled. The problem with this, though, is that you can no longer change the size. Like, if I want to make my sky bigger now, I'll try to make it bigger, but then that just happens. So go back, revert everything back to your original, and make sure this is, keep Control-Z until this says simple. Now you can stretch it again. So stretch it first, and then go to tiled. And once you're in tiled, there's kind of no going back. So create your sky. Because if we go back to simple, you'll see it stretches out. I mean, it looks, it still looks good, kinda, I guess. It doesn't look terrible. But yeah, so simple, stretch it out, and then go to tiled. Now that we're in tiled, well, we finished our sky. Now let's go and create some clouds. So in our 2048 by or actually in our PNG, there's a clouds part. In our 128 by 128. Grab a cloud, put it in, bam, you got a cloud. Control D, duplicate, you got more clouds. And now we're gonna add some hills. Those are in new background. So open the new background, PNG 2048 by 1024, all mid, front, and back. So drag back into hills, drag mid into hills, drag front into hills. Nice. Okay. So you'll notice that the overlapping is kind of weird right now. So you can't even see some of the, like, it's all screwed up. To fix this, we got to work with our sorting layers. I already have a background. I'm going to delete it to show you guys what it looks like. So what I did here is just pressed on sorting layer, add sorting layer, and press the plus button, add a background layer, and then right now the background is in front of our default. We want to put our background behind our default. Do that, and then press on your objects, go to sorting layer, change it to background. And we're going to actually do that for all our objects. So in our hierarchy, select all of our objects and change the sorting layer to background. Now they're all on the same layer. They're going to be behind the player and behind the tile map, which is good. But now they're like randomly overlapping each other because they're all on the same layer. To fix this, we're going to put our sky in the back, change it to -1. Put our clouds in the very front, change it to like 10. Put our back at 0, mid at 1, front at 2. Now everything should work or look look correct. Let's move our our front up a little bit. Select all of them. You can do that in a hierarchy too. Select all of them, set them up the way you want, change the draw mode to tiled, and then you can just drag them all at the same time. Pretty handy. There you go. You got your tiles and your background.
My name's Colin. I'm going to walk you through doing sprites in Unity. The first thing I'm going to cover is importing from a PNG. This is something you want to do if you just find an image you like, a sprite sheet image you like. You can do it with individual images, but obviously that's going to be a lot harder. You're going to want to look for something like a sprite sheet, which has the different animations all in a row for you. Obviously it has a background, so we need to remove that. For that, it's pretty simple. I just looked up, you just look up on Google, free background remover. Oh. And this is the one I used. It gives you one free that keeps the quality. Otherwise, you can just have a little loss in quality on the image. Not a big deal depending on what you're doing. I'm sure you could find others, but this one's really simple. You just drag and drop into here and you download it. Basically, you want to put that file into your Sprites folder. I've got that here, and I have the before just in case I need it again, and then the background removed one. As you can see in this little box down here, this is the auto splitting that Unity tries to do. So if we go ahead and open that up, we can see what it's attempting to do is dissect each image, but it's obviously failing. This sprite is not 1, 2, and 3. You would just want this box here. And the other issue would be you want these boxes the same size because one, it's gonna, when it runs this and it sees this box of sprites and then this box a little bit bigger, it's gonna kind of make the sprite jump around, and it's really not what we want. And so for this, you have different options. We're using automatic. It starts with automatic, and that's what this crazy mess is. I'll show you this later on importing sprites from asset packages. Usually it does automatic pretty well. The pivot position is where it draws the square from, and if automatic almost does it well, but let's say, I'll show you this again on the later one, if you have something sticking out, like this has an object that it shoots, you would want to draw this from maybe bottom left, and so that way it would draw the same size, but we'll see that later. The other options are grid by cell size, if you know the pixel width of your image exactly, that's super nice, and if they're all perfectly aligned. The other one, they also need to be pretty well aligned, grid by cell count, and this would be, I can basically just count, well, I have 1, 2, 3, 4, 5, 6, and so I would do 6 columns by 6 rows. And you can see the red lines is what it's wanting to dissect, but you can see this image, bottom left, this one sits here, and top middle on this one. And so these rows to the edge of the image aren't very well aligned, and you can use offsets to try to, on the X and Y, to try to shift it. But if they aren't aligned with each other, then that was never going to work. And so what I did here to solve this is I took this image, I just took it into my on-device simple image editor, and I just took a crop of, all I wanted was the fly. And you can take, all of them, but I just took a crop of this and I aligned it with the tallest parts of any of the images. So you wouldn't want to line it up with the wings here because it would cut off those wings. So you want to line it up with top wings and the bottom feet, and then from tail to head. And it gets me this image. And that's this guy right here. Then if we open this guy, if we did an automatic slice, oh, well, I've modified this afterward, but it actually had these boxes kind of like this. And then this one was like this, and so it didn't really do it exactly like I wanted to. But that's what's great, is you can simply just grab the box and boom. The only thing you want to worry about here is if you're manually changing. For this, the heights are all going to be the same, hopefully, because I'm just going from top to bottom of the image. But you would want the widths the same as well. So I'm going off the tail for these guys, and then I think I made these all 133, and you want to make sure it just goes out to 133, but starts at the tail. This is ensuring that if the dragon sprite or any other sprite you're using were to extend, like increase in length, you would want to go off of a width that would be the widest. And so if this, let's say the middle sprite, his head was more out here, I would want to align it where the head would touch, and then make this one and every other one the same width. You just want consistency, otherwise it's going to make the sprite jump around. But I just went through and made sure all the width started at the tail and went to 133, just like that. And that's all you need for the splicing. Again, you can do, if you're doing it from a PNG like this, it's going to be a little bit harder, but totally doable like this. And if they're not aligned, you can just crop it out. And then we'll save this. And then I haven't put this one into effect yet, but I'll show you one that I have. It's for our little character guy here. This is my night sprite. This came from an asset. And so I downloaded it just online. If you look up free 2D sprite assets, itch.io has a lot to take from. They'll give you a huge package, and somewhere in the package there's going to be a folder of sprites. All I did was I grabbed the night sprite and popped it in here, and this is what was inside. These are made by me, so you won't have these things in, but we'll learn how to make them here in a minute. They should have these though, and they should automatically be selected off. If they're not, same thing as the dragon, we're just going to go in the sprite editor, and this is something where the automatic center worked amazing for me, and it's that's all it needed. Sometimes, let's see, I didn't use walk, so let's look at the run. Yeah, so in this case, I just used the automatic and I plugged it in. And I didn't need to have the same widths. And that's because of where it's rendering from, the center. They're all the same, and so it's not a big deal because it's proportionally long. I just need to make sure that the center is from. But if you're having issues with the sprite jumping, just ensuring that the widths and the heights are the same is all you need to do. But once you've split it up like that, this little arrow it should show you the individual images. And so we can take our character, this guy's named Player, and we can go into Window, Animation, and boom, it'll pop in right here. We can, I have clips here that I've already made. You can create a new clip, and let's call it tutorial run animation, just because I already have a run that I'm using, but just to show you guys what it would look like fresh. This is your timeline, and basically you want to take all of these, you can do a shift click to grab them all at once, or you can do them one at a time. We're just going to drag and drop them in here. If you click this little arrow, it should render the images sometime when it loads. Right now they're just dots, but you should be able to click on, oh, just, well, anyways, they should be in the correct order because I grabbed them in that order. And we're going to drag and drop, and if we play this animation now, we can see he runs really, really fast. So we don't want that. We're going to grab all of them and we're going to space the first and second out 5, and then the next one's out another 5, and just so on. And you can do this by any number you want. I chose 5 because it's an even number and it doesn't look too fast. Boom, out to 30, and then 35. And now you can see when we play this, much more moderate running pace. There's also a way to change these speeds in the animator, but I prefer it's just easier to just do it here. That way it doesn't mess with anything else. So now we have our clip. It's called tutorial run. We're going to want to go into But now we have our clip, tutorial run. We can see that also showed up here. And if we go into our player, we're going to want to add what's called the animator. And so we can add that component here. You just type in animator. And you pop that guy right there. And then we can go into window, animation, animator, and it'll open this guy. When you first open this, there's not really good a way to move around. When you first open this, you'll see a bunch of these things that you've made, the clips, but they won't be connected like this. And so I can show you, let me disconnect this guy. You can just click on them and delete them. But you'll just have a bunch of these. This is kind of the coding without the coding part of the animation. Oh, just like tutorial run. Wasn't here before, now it is, and it's just sitting here. Entry is usually going to be pointing to an orange one, whatever one you have in first, and that's going to be the default. If you want a different default, you can just click here, and entry will go to this. That just means whenever you start the game, what it's going to run first, and I want that to be an idle. Then we can define when we want to change the animation. And so this is going to be the finite state machine. You're going to click on, here, let's start with jump. We want to transfer to a jump at any point when we're in the air, let's say. And so whether I'm running or I'm idling, I don't care, I want to go to jump. So we can use this, what's called any state. And we can make a transition to character jump. And then we can click on this little transition and we can see how it's going to work here. We need what's called parameters. And that's going to trigger the transitions and be the coding aspect of it. And so we can make a new parameter. For jump, I have one here. It's a Boolean, so on or off. And basically in my code, which I'll show you here in a minute, if I'm in the air, I set is jumping as true. If I'm grounded, I set it to false. And if it's true, I want to be playing my jump animation. And so in this transition, I'm going to add the parameter, and it'll have you select out of these parameters that you've made the is jumping one, which we have right here, we've made. If you make a new one, just to show you, Boolean, it just has you type in a name, test, boom. That's all you need. And so now we could, in this transition, we could add test if we want, just like that. But we're going to use is jumping, and we want it to transfer from any state to character jump when that is true. And now if you run this, oh, I guess I should show you the code first for it. Stop that. Let's go into our player controller. I'm going to be doing this from the player controller because that's directly where I interact with when I'm going left or going right or jumping. It's going to be stored right in here. And so we're gonna check in our movement. I think I have this guy right here. Oh, that's running. Where is the check ground function? Here we go. So this function checks our ground. And basically, if we're on the ground, we have a parameter already set to make sure that we can't jump when we're not on the ground. So this is a perfect place to put this in. If ground is true, then I'm going to set the parameter of is jumping as false. And if grounded is false, that means I'm in the air. That means I'm going to do animator set bool is jumping true. And so that this little line of code, it's basically saying go to the animator in here, set the boolean of is jumping, set it, and check that box. That's all that does, and this one unchecks the box. And so when that happens, we can see I have a transition state to it. See, I started in the air, so it transferred from any state to jump, but there's no way to leave it. So I'm on the ground, but I'm still in my jump. And so we need to make a transition. Just to make it simple, I'm going to put it to the idle, because if I was running, all it would need to do is go to idle and then to run directly. So not a big deal with there, but I'm going to make this arrow. I'm going to add is jumping and false. And so with that little change, we can see that when I'm in the air, it goes to jump. Oh, one other thing I forgot to show you, which is why I did that. It went to character jump, but it's going to wait for it to finish before it goes to character idle. And that's not what we want. And so in the transition, this little checkbox here has exit time. Basically means, should I wait for the animation to finish before I transition to the next? We don't want that. Once we hit the ground, we want to transition into not a jumping state. And if this checkbox is unclicked, that's not all you need to do, because this is also acting like an exit time. And so it waits at least 0.25 seconds before it transitions. We don't want that, because if we do a little jump and we hit the ground really soon, let's say 0.1, we want to transition immediately. So we're going to set that to 0. We also want to do that for the transition to the jump, because once I'm off the ground, I want to trigger the jump. So that checkbox is already unchecked, but we're going to set this to 0. Okay, now if we play this, there we go. Once we hit the ground, we're in idle. Once we're off, we're in jump. Just like that. And you can see the transitions happening here. And it's the same deal here with the character run. All I have is a boolean if I'm running, which I put directly into my get player movement. If I'm moving in a positive direction, I set running to true. If I'm moving in a negative direction, I set running to true. And then here, in order to get the animation, instead of having two different animations, one left and one right, it's easier to just do a flip function like this. And so I don't want to be flipping all the time, so I want to check that I'm facing the right direction. And if I am, I'm going to flip. And if I'm not facing right, I'm going to flip for going to the right. So if this is saying when I'm going right, if I'm facing left, I need to flip. And then I set my running true. Doesn't matter the order of those, but I'll show you my flip function here. This is something pretty common. You can just look up how it works. What it just takes the vector 3 and it's going to do a transform, and it's just going to multiply the correct x position to -1, which just is a rotation, and you can see that here happening. It's basically just doing this on the x position -1. That's all it's doing whenever I tell it to flip. And so that way we have the same running animation, but it's going to the left or going to the right. And so that's pretty much it for the finite state machine. Minimal coding required. Only need these little setting bools, triggers. I'll show you a trigger. I have a character hurt, and so let's go over to our little enemy that we have. Gotta wait for the platform. And so if we touch it, all right, and I should mention triggers. I use a trigger for the character hurt. So when the function in the game editor, in the player controller, or anywhere, we just have a function which is hurt, which decreases the player life, stuff like that. And all I have here is the animator. Instead of set bool, it's going to be set trigger, and it doesn't need a true or false because it's just like a button. It's basically going to click a button trigger, and it's called trigger hurt. And I have that here, trigger hurt, and you can see that that is just going to be coming from any state. And I also have 0 exit time and a 0 right there. Basically for any 2D animation, unless it's a specific case with the way the animation interacts with an object, you don't really want exit time because it makes the transitions really snappy. Yeah, that's about all it I have for you. Covered the asset importing and the PNG and the finite state machine. Isaac's going to cover tile mapping. That's how you get this stuff right here and the background. But all right.
Hi everyone. Now we'll go ahead and go over ground enemies. Currently the sprites have not been implemented for them, but what we'll go ahead and do is we'll go over a couple different behaviors today. One, just kind of this patrolling behavior where they go back and forth on their exact same platform level. But then as well, as soon as they have a target, it'll have them chase the target a little bit. They won't be able to go up, and then they will stop at walls and then go back and forth if there are walls. As well, we'll go ahead and do when you run into them, or when they run into you, that you will take damage, and then as well when you go on top of them and stomp on them, they will go ahead and die. And so let's go ahead and get into the code. So we'll go ahead and call this script the ground enemy script. And then there are a few different variables that are set inside of the inspector. Just the minimum information possible, made accessible. And then as well, we just have some caching variables to make sure that it's in an acceptable format and not just reallocating things every single frame. And then as well, we have the player target variable, which is found in the start message, which is sent by Unity. And so then at that point, every single update frame, we go ahead and check the target validity. And so that's pretty much just whether the player is within the view distance or if it's outside of the view distance. And then after that, we check to see if the enemy can walk continue walking in front of them. And then we have the check whether there's a wall in front of them. And then after that, we go ahead and check and see if they have a target. And if so, they kind of go ahead and follow them as well, as long as there is ground in front of them and they are not running into a wall. And then if they don't have any ground in front of them, then we go ahead and just turn them around and then just continue to move in the direction where there is ground in front of them. And so then this right here is just kind of to debug some information in the scene view, which just makes it a little bit easier to see whether it's actually working or not. So this is the ray that actually hits the ground. And then this is the ray that actually hits the wall. And so kind of for the first of the couple different checks, which was the walkable ground, what we go ahead and do is we do a ray cast, which is just the position of the enemy plus a little bit of an offset, which I believe right now is 0.5 in the X direction, and then that ends up switching every single time. So right now on the prefab, yeah, it's just 0.5 because the scale of the enemy is 1. And so then at that point, it just is on the very edge of the enemy, as you can kind of see right here. So edge of the enemy, and then it'll end up changing. And then that ends up changing the check for the wall as well. And so what we go ahead and do is we do the transform position plus the ray offset, which is by a magnitude of 0.5 in the X direction, and then the direction itself is vector 2 dot down, which is just a vector 2 of 0 in the X component, -1 in the Y component, and then distance of ray distance, which is 1 when it is not chasing the player, and then 2 when it is chasing the player. And then we go ahead and get the layer mask for the ground layer. And then after we get this raycast hit back from physics2d.raycast, we check to see if the collider is null. And if it is, then that means that there is no ground where they would want to move next. And then we go ahead and return false, and then we store that in this Boolean variable, or true, and we as well store that in the Boolean variable. And then after that, we'll go ahead and check the wall in front, which is pretty much the exact same thing. And so just instead of having the direction as vector 2 dot down, what we go ahead and do is vector 2 dot right times move direction dot x. And so this is always a normalized value between -1 and 1. And so then at that point, since right is always 1, then if they're moving to the left, then this will just tell it to have the direction as left. And then we go ahead and have this as a value of 0.51 since the scale is 1. Generally not super great practice to have hard-coded values. Magic numbers, I think that they're called. And so you could probably even do this as like transform dot local scale dot x or something like that divided by 2. And then at that point it'd work just as well. And then we also get the layer mask for ground, since any of the walls, quote unquote, at this point would also be part of the ground, since as you can see right here, this would be ground right here, this would be ground right here, this would be ground. And so yeah. And then as well, I guess before we do either of those checks, we do the check target validity, which then just takes the local position of the player, and then we make sure that the z-axis is set to 0 because this is 2D, and so there should be no distance. And just for whatever reason, if there is a distance in the z-axis, we go ahead and get rid of that, and then we just want to make sure and see kind of what the distance in the x-axis is. And then we go ahead and do the length of this entire array, or of this entire vector. And then we just do the square distance of that instead of taking a square root, because that'll also be a little bit quicker. And then if there's no target, then we just check the distance to the ground as a distance of 1 so that it cannot go down any levels. And then we say that it doesn't have a target, go ahead and return. And then as well after that, if the player is within the view distance squared, or actually within the view distance, then we go ahead and check and see if the player is in front of the enemy. So local position, whether it's to the left or right, and then we take the absolute position of that local position to normalize it, so then it'll be either -1 or 1, just to say whether it's left or right. And then at that point we check that based on the movement distance as well, and then we normalize that to be -1 or 1. And then after we do all of that, we take the absolute value of the local position minus the movement direction, and then we see if that total absolute value is less than 0.001. Since at that point that means that they are in the same direction. And then we say that they have a target, and we do this ray distance as equal to 2, because then that means that they can drop down by a level. And then that means that they can also chase the player. And so then that's all for the movement at this point. And then for whenever the player ends up entering the enemy's collision or the collider, then we go ahead and do this on collision, enter 2D, which is a message passed by Unity. And then we go ahead and check and see this stomp tag is just on the collider that is underneath the player. And then there's also the player value. And so if it's the player that it actually goes into, then we go ahead and deal 10 damage to the player. Otherwise, if it hits the stomp collider, then we go ahead and just deactivate this game object. As well, we also have this on trigger enter 2D, and it has this exact same code for the stomp, since it is actually a trigger that we use instead of a collider itself. So this code is actually not specifically necessary, but for whatever reason, if it gets changed to a collider instead of a trigger, then it will still work at that point. And so all of that code for the AI is about, well, the entire file is 175 lines. And it allows it to move down and then chase the player, patrol behavior, and all of that. So thank you very much.
I'm going to be showing you an overly complicated way of making a simple flying enemy. So to begin, you're going to need 2 separate packages. The first one is available online. It is called the NavMesh Plus. This allows for the use of a nav mesh in a 2D environment, which is Unity normally cannot handle. So you're going to go ahead and clone or download this however you can. Once you have it saved locally to your computer, go ahead and look for the NavMesh Components folder. Once you've located that, drag and drop the NavMesh Components folder directly into your Assets folder. Once you have the NavMesh components installed, go ahead and open up your package manager, and you're going to go to your Unity registry and search for AI Navigation. Once you have AI Navigation found, go ahead and install it. And the next step is to then get a NavMesh in our background. So create an empty object and name it NavMesh, something to that effect. And now to our NavMesh, we are going to be adding the navigational surface from NavMesh Plus package, and the collect sources 2D also from the NavMesh Plus package. Next, we're going to dictate where our actual NavMesh is going to be. Since it's a flying enemy, I'm going to use the sky, as provided by my other teammates.
to our sky, we're going to add a navigation modifier. That'll let it communicate with the nav mesh. Then next, we're going to go ahead and let's make a 2D, another enemy out of a circle and name it something like flying enemy. There we are. Now, the flying enemy is going to have some unique scripting to it. So, and rather than bore you with a lengthy demonstration of my poor typing skills, I will instead simply show you the code and explain it to you. So you'll first get the Unity Engine AI. You can serialize this in order to set the target using the Unity interface. Declare the agent. These two parameters are set to false because using a nav mesh agent will cause it to reorient. And then you'll finally set the destination to the target position, whatever that is set in your serialized field. Now we'll come back to this, and here is our flying enemy. So we will apply our script. There we are. And now to make sure that our flying enemy is going after the right target, we will bring over the player. And next, to make sure it can communicate with our nav mesh, we'll give it a nav mesh agent, the built-in nav mesh agent from Unity. Now that we have all that set up, we'll come back to our nav mesh. Go ahead and hit rotate surface to XY. That will align everything. And then hit bake. All right, that blue rectangle you see is the navigable area for the enemy. So at this point, the enemy should start to pursue, and we should see some movement when we test it. So this is using Unity's built-in pathing system. There we go. As you can see, it chases wherever the player will go. Interestingly, the built-in pathing system is in fact A star. There are many implementations of A star out there. Unity's AI navigation system is one of them. So the NavMesh Plus repo that we are using allows us to use the Unity's A star pathing system in a 2D environment. All right, that has been a demonstration of how to get a simple chase enemy to follow the player. Now, if you wanted to do something a little more interesting, we can set that up using our some other components as created by my fellow teammates. For example, the collision event script. This will allow it to interact with the player. And we can set the hurt like so. Now, except I did forget two small things. I do need the rigid body 2D and the circle collider. Otherwise, won't have much happening. And for the rigid body 2D, let's set that to kinematic as well, so we actually have some action out of our flying enemy. Here we go. So now we can run. It still is in full pursuit, and when it catches you, it does some damage. All right, this has been a simple flying enemy implemented using a probably very complicated system. Thank you for watching.
Hello, I will teach you how to create an infinite scrolling parallax background. A parallax background means that the background layers scroll differently from another background layer, typically having closer layers move faster than further layers. To start, Prepare your background objects, set them on the scene, and then put them into sorting layers as you wish. Then create a mono behavior script for parallaxing backgrounds. For the parallax effect, you will need a float for the start position of the camera. This will detect which way the background should scroll relative to camera movement. You will also need a float for speed and a Gabe object variable to store your main camera. Make sure you initialize your start position in the start method as well. To avoid stuttering in your background scrolling, change your update method to fixed update. This equation for distance will transform the background according to the distance in respect to the camera movement. And this will be transformed every single time there is an update. Now for infinite scrolling, you will detect if the camera has moved the length of the background, then move the background up a screen length. This will be smooth if you have a repeating background. For this, you will need a length variable. You will then initialize this length variable to the bounds of your background object. In your fixed update method, add this equation to track movement of the camera in relation to the background. Then this if statement will move the background depending if the movement variable exceeds the length of the background. Back to our scene view. For the background layer, you want to scroll infinitely, duplicate it twice, set these two copies as children of the original, then it will move along with the parent. Then drag these children to the left and right of the parent in the scene so it repeats smoothly. Repeat this for all background layers. Last step is to drag the script to the background. Make sure you only drag the script to the parents of the two children backgrounds. Set the speed according to how fast you want the background to move, and drag and drop the main camera object in your script. Then you'll have a complete parallaxing background.
So right about now, you're probably wondering how you were going to go ahead and make yourself have some music for your game. Now, essentially, what we're going to make is a sound effects handler. So you're going to go ahead and right-click in the hierarchy, create an empty object, call this SFX handler. And then go ahead and create another empty object in here, and we're going to call this one music. From here, you're going to go ahead and add component audio source. And then from there, you're going to take your totally not copyrighted music, 100%, and then you're going to go ahead and make sure it loops. And now, if we play our game, and make sure to set the volume a bit lower to kind of gauge where you want it. And then once again, once it's load. So you can see that's pretty loud, so we can go ahead and take it down a bit. And now we can kind of have some nice music in the background. So now make sure one thing you gotta realize is that when you make changes inside of the Unity editor, it does not save. So make sure you copy the value that you decided on and paste it back in. Make a prefabs folder similar to this one, and then drag this into here, and it'll make yourself a new prefab so that any scene at all, you could just drag it straight in and it'll know what to do. So to go on second here, you might be wondering how to make a object make a sound when you interact with it. So let's take this coin for example. Now we have music in our game. However, we don't have any other sounds. When you pick up this coin, it should make a sort of da-doong sound or something. Now, one cool thing is you can make your way over here. You didn't see that. This is totally my own music. To this little website right here called sfxr.me. It's a free open source website you can use to make your own 8-bit sounds. So I always try to set that pretty low. And then, you can do that, and you can mess with all these, things to make your own music or, sound effects and whatnot. But what we're interested in is what I already have here, which is a coin pickup sound effect. So what we'll go ahead and do is we'll make a new script. If I could find the scripting area. Call this play sound on interact. Okay. So now we'll go ahead and open this. And Unity will take 30 years to load. And you're going to go ahead and make an audio source. Make it public. And then you're going to need another public audio. We'll need an audio clip this time. You'll play this, name this sound effect. Now what you're going to want to do is you're going to want to type in on trigger or void on trigger. Oh, if I could spell. Trigger enter. And then collider other. If other dot tag equals player. Oops. Press and enter there. Then you're going to go ahead and say audio source play just like that. Then you're also going to want to go above it and say audio source dot clip equals sound effect. So now if we go back into Unity, not the hub, but Unity, should compile and everything should work perfectly. First try. And it does. Now you could just use this if you really wanted to, but I think it's better not to, because now we can use our sound effects handler. Create a new empty in there. We'll call this game SFX. We're going to go ahead and add the play sound script here. Oh, apparently I broke it. Oh, if this happens, you just need to put this little colon here and then mono behavior. In order to apply scripts to a object in Unity, it has to derive from a mono behavior. That's a whoopsie on my end. Now, drag this thingy on here. You're going to link game sound effects once we add an audio source to it, I suppose. Set this down, obviously. Over here to coin, or whatever you're putting this on. Game SFX. And then the sound effect, which will be our coin pickup. And theoretically, this should now work. Because our guy here is marked as player, and he's going to be collecting. I think I set it to... Oh, it didn't work. I wonder why it didn't work. One second while I fix it. Okay, I realize now what I messed up on. It should be marked as on collider enter 2D and collider. And collider 2D. Just like that. Now this doesn't have to be named other. You could name this col or collider, whatever you want. I just use other because it makes it a little bit easier. Basically what this is saying is the object that's colliding with it. Now it should work. Oh, okay, well. Alright, let's go ahead and test it now to see if it works. And it does. We go ahead and enable it again. Now, one other thing you might be wondering is how do we make some nice spatial or parallax audio. For that, you're going to want to go ahead and create an empty object, add an audio source, set this to 3D, all the way over here at 1, set that to linear, and then set the max distance to about 100, or depending on how far you want the player to be able to go. It can all be visualized with this little thing right here. So now, if you have an audio listener on here, you'll want to remove it, and then set the audio listener to be on the player. This will allow for basically it to recognize the player as the audio listener. You can also go ahead and set that a bit lower. So now, if we go ahead and put this over here and then add a sound effect like get hit, put that maybe down there. Theoretically speaking, if we loop it, you should be able to tell when you run up to something that is playing. Still notice we can't hear it. And then the closer we get, the further away we get, the quieter it gets. And you can adjust these settings as you see fit. And that's how you add sound design to your game.
Hello everyone, welcome back to another part of the CS383 platformer tutorial. Today we're going to talk about movement and control schemes. We're going to start with a method called getKey and getKeyDown, which will just grab the keys of your keyboard specifically, and it'll return a Boolean true or false so that you can check if that key is being pressed. So here we have a serialized field. We're just going to go ahead and initialize this variable with the string that we can change in the inspector, which is why it's serialized. And the method getKeyDown will accept this string and return a Boolean if it is pressed. And so we can go ahead and take a look at that. Go ahead and look in our getPlayerMovement function. So here we have it right here. You can see it's a method on the input, and then we're going to feed it this string. This will return true or false if jump, which we have mapped to W right now, is pressed. And then when it is, we'll go ahead and take our B, which is going to be our rigid body component that we initialize up here with the get component, so we can grab the rigid body of our player and manipulate it. And then rigid body has a linear velocity that takes a vector, and then we'll just go ahead and add the X, so the up axis, and then we'll add the jump force, which is just going to be a another variable of ours, a float in this case, so we can add some height. And that's pretty much all there is to the getKeyDown. This is built in, and you can look up the key codes for all of the buttons on your keyboard, and then just put them in an if statement, and then have different kind of actions happen. So let's go ahead and test this out, make sure this function is working specifically. Go ahead and hit play on here. And I know you can't see my keyboard, but I'm going to go ahead and press the W key, and bingo, our player gets that jump, and it adds it to its X axis so that it can move and then come back down. Okay, great. That works pretty well, but what if we want to be able to map W or map jump to multiple keys, maybe even multiple keys at once, or switch between keys? We don't really want to have to feed in different strings and then check for each button that we want to map. We have a ton of variables here. You might end up with the whole keyboard on here. So let's go ahead and look at a slightly different way that we can grab that input and have it mapped to kind of different things. So we'll go ahead and now take a look at the input manager. And the input manager is also goes off the input class, and it has a function called getButtonDown. So you have to it's a little more setup because the just checking the keyboard is built in, but you'll have to set this one up. So you can see I have it, I have this OR statement, and I'm going to use the get button down instead, and then I just have another string jump. So we'll go ahead and look at where the string's coming from and what this is actually doing here. So in order to mess with the input manager, you go to edit, and then you'll scroll down to project settings. And then in the input manager here, we have these axes. And we can use all of these and map them to different controls. And this is actually going to return an array of these, so we can increase and decrease these numbers however we want. You can have as many of these as you want. And so since we were talking about the jump, let's go ahead and look at that. And as you can see here, I've got 2 of these. So this jump is going to, you name it here, you can name it whatever you want. And then these are the important ones, the negative and positive button, because this isn't going to return a Boolean. It's going to return a number between -1 and 1. And when you press the negative button, it'll go towards the -1 side. And when you press the positive button, it'll go towards the positive side. And similar to the key codes, Unity is going to build in these names, so you do have to spell these correctly and with the correct capitalization. So space is for the space bar here. And so we'll go to the second one. So this is also the same name, so these will both be called at the same time to check if it's negative or positive. But this one, instead, I have this name called joystick button 0. And this is actually going to get input from a joystick or some kind of gamepad or controller. And button 0 specifically, you'll have to look up the mapping on all of these because they'll be different depending on what kind of controller you're using. But this is the A button on an Xbox controller or generic Microsoft controllers. With these ones specifically, you can actually start messing with some of these other settings like sensitivity. And the sensitivity will just make getting to -1 or 1 even faster, which is not really important if you're using keyboards because you can just press up and down. But on a joystick, you have a little bit of run between whether you're like fully right or fully left, and this will just get you there faster for even quicker movement. But this obviously isn't a joystick, it's a button, which is why we're using get button. So let's go ahead and check this one out. And then just so that we make sure everything is working here, I have a Xbox controller plugged into my computer. Just go ahead and pull up these properties, make sure that that's working. So, okay, I can move the analog stick, and then I can press, that's the A button right there. These aren't the mappings, by the way. This says 1, but it's not going to correspond to Unity at all. So, cool, our controller is working. And now let's just make sure that it's working in the game. So again, we're going to go ahead and call this input. And it'll just do the exact same thing as if we pressed the W key, except we can get it from many more places using the get button. So we'll go ahead and play again. And again, I know you can't see specifically what I'm pressing, but I'll go ahead and let you know. So now I'm going to try the space bar instead of the W key. Okay, that's working as well. And then you can see we can still press W to jump. And then now I'm going to go ahead and press the A button on the Xbox controller. And excellent. So now you can see we have multiple inputs for the jump button. And even the W, we could have went ahead and just used a button. We could have created another jump in the axis and mapped W as well. So that is how we kind of create a spectrum of control types. But what about for our movement specifically in the analog stick? So this one is going to be the final method we'll talk about. It's going to be get axis. So go ahead and go back up to the top here. All of our functions, and we're going to have to initialize this function. We'll just call it move here. It's just going to be a private float. We don't really need to expose that to anything. And then in the update, we're going to go ahead and initialize this move with the input get axis method and then horizontal. So we'll go ahead and check out horizontal in our input manager and see what's going on with that. So here we have the top horizontal, and you can see we have left and right. And so this is really nice. It's different from the buttons because then we'll actually get 2 different values instead of just always getting +1. So it's basically like a built-in if statement. So you don't have to actually wrap like you would if you were using get key down. You would have to have an if statement. If it's left, you'd add a negative, and then if it's right, you'd add a positive value. But that's all just built in for us. So if we press left, it'll return -1. If we press right, it'll return +1. But that's obviously not the only horizontal we're going to have because we have our controller as well. So let's go ahead and look at this one. And this one is going to be set up a little bit differently. You see that these don't have anything in here because the joysticks aren't mapped to specific, they're not buttons. So the only thing that you have to change, we can go up, look at this one. So we have key and mouse button here as the type, which is going to check keyboard inputs. But for joysticks, we don't want to check keyboard inputs. We want to check the joystick axis. And specifically, we want to check the x-axis of the joystick. So we can have that. It's pretty simple setup there. And just as a note, for the buttons, you can see here that I'm not checking the joystick, even though I'm using a gamepad. That's because it is a button, and it'll be checked the same way a button on a keyboard is checked. So let's go ahead and take a look at that code one more time, and then make sure everything with that is working. So we get the move, we get the axis horizontal, so now this move is going to store the value between -1 and 1. This if statement actually isn't necessary for movement itself, it's actually just facilitating another piece of our code here, which will be explained in a different part. So we'll get move, and then we'll go ahead and grab the linear velocity of the rigid body again, create a new vector for it. And this time we'll just multiply move, which is going to be either 1 or -1, so that'll choose our direction here. Multiply that by our max speed variable, which we have in our inspector here, so we can change how fast this is going. And then this is just to make sure that the y position remains constant. So we'll just grab the linear velocity, the current linear velocity of the rigid body, and then add it back into the vector so that it always remains the same, so you don't kind of move diagonally in weird ways. Okay, let's go ahead and take a look at all that, make sure that we can move our player around. Alright, so I'm going to go ahead and test the keyboard first. It's looking good. We can move back and forth exactly as we expect. And then in the editor here, if we want, we can change the speed, so you can slow it down or speed it up. Awesome. And then I'm going to go ahead and switch to the controller here. So I'm going to go ahead and use the left analog stick here, and boom, you can see. And also you can see that even though the speed is the same, the analog stick is a little bit faster because of how the sensitivity works. It'll actually get to -1 more quickly as the controller switches from side to side, which gives you a little bit more responsive. It's not necessarily faster if you just hold it in a single direction, but it's something you'll have to look out for. Make sure your sensitivity, if you want it to, matches exactly how the keyboard controls feel. And with all that, now we can see we have a pretty decent character controller. We can jump around, we can move. I'm doing all this on the controller. We can jump over to here and can just kind of start flying around. Okay, so that's basically movement. The input manager is going to be extremely helpful with making sure we map and configure all these controls. And we can pretty much do this for anything that we want. Outside of even player movement, we can do it to make sure that our inputs get from the controller and the keyboard when surfing through menus or anything like that. This version that I have here doesn't currently have any menus, but I can go ahead and just show you another way. And we'll go ahead and edit this one and kind of make sure it's all working. So this is just a function that'll restart the game if we get a game over screen. And we want that to happen if we press, we're going to try to use get key down here for R. And then we're using get input. This is the submit, which we can take a look at here in a second, but just make sure this is working first. So go ahead, start up the game again. And let's go ahead and fall off so we can get our game over screen. Alright, we got the game over. And now we're going to go ahead and press R. Perfect, it'll bring us back. And then that submit, I have mapped to start, so we'll press start here. And then just to show you kind of how versatile the get button input can be, we'll go ahead and change this. We'll just get rid of this completely. So we're only checking get button submit. Oops, let's go ahead and stop that so the code can recompile. And then once that's done, okay. And let's go back into our manager here and collapse these. And here's our submit. So we have the enter button already entered here. That's fine. We can just use that. Here's the one that I created with the joystick. I used 6 and 7. So these are the start and the select buttons. You can have alternative buttons for all of these. So you don't even have to create a new one. If you just want 2 controls, you can have that on one axis, and if you want even more than that, you can create more. I like to keep the joysticks and the keyboard controls separate. That way it's much easier if you want to create a system to select between them rather than having them both always be available at the same time. Then you can rename this one really easily to like submit keyboard, and then this one submit controller, and then they'll have their different values and such, and you can have something to swap between them in a menu or something like that. So we'll go ahead and test this out. We didn't even make any changes here. All we did was delete our get key button down by pressing R. So now we're just going to do enter. We could enter at R here too, but I think enter is fine. Just to see how easy this can be once you have it all set up. Go ahead and press start. Alright, go ahead and get that game over screen again. I'm going to go ahead and press enter on the keyboard. And beautiful. Alright. That's about it for this specific character controller, how to swap it to between a keyboard and a controller. And I hope this gives you guys plenty of ideas for making your own character controllers. Character controllers are pretty important for 2D platformers, specifically because how you decide to implement this stuff and how everything feels, your jump force and your max speed and all this stuff, friction, is all going to make your game stand out and become very unique.